Ahi ahi Marie. Good afternoon, everyone, and welcome to today's CPD webinar brought to you by Rinnai, New Zealand. I'm Alice Wu, National Specification Manager from Rinnai, your host and moderator. Thank you for taking the time to join us today as we talk about designing with wood burners. While we're waiting for everyone to arrive into the room, let's test our chat function by typing our answers for this question. Your ultimate winter comfort combo. Again, what is your ultimate winter comfort combo? Please type your answers in the chat. Is it a wood fire with a hot drink, a cozy blanket, a good book to read, a movie? Let us know by using the chat function. A book to read. Thank you, Peter. I hope everyone's chat function is working. Waiting for the results to come back. Or perhaps just wood fire by itself for some peace and quiet. Yes, we've got wood fire, dog at feet. Oh, that is a really good combination, Campbell. Thanks, Tristan. That's a really good answer. All right. Well, thank you for sharing your answers and good to know chat is working. Let's start. Welcome to today's CPD webinar brought to you by Rinnai, New Zealand. I'm Alice Wu, National Specification Manager from Rinnai, your host and moderator. Thank you for taking the time to join us today as we talk about a hot topic in winter, designing with wood burners. We'll also be looking at case study featuring a real project and client outcome. This webinar aims to assist architects and specifiers to gain a better understanding when designing wood burners and specification information. Today's format will be 40 minutes of presentation followed by Q&A worth 10 NZROB CPD points. For smooth running of the presentation, we kindly ask you to submit your questions in the Q&A section and we'll answer them during Q&A time. Again, please type your questions in the Q&A section and we'll answer them during Q&A time. If you have joined us via the Teams web format and may not have all the functionalities or simply too shy to ask questions publicly, don't worry, we'll have our contact details at the end for you to send questions through privately. Now let's start with a 1-minute introduction about Rinnai. We are celebrating our 50th anniversary in New Zealand this year. With over 1 million appliances installed into Kiwi homes and businesses, Rinnai New Zealand has established a proud reputation for quality and reliability. Rinnai's mission is creating a sustainable, healthy and comfortable way of living. We provide a range of products and services that covers climate control and water heating solutions. For water heating, Rinnai has hot water heat pump, gas infinities and hot water cylinders, and commercial solutions. For climate control, we have Warmington wood fires, electric fireplaces, gas central heating, and heat pumps. Rinnai acquired the Warmington brand in August 2023. Rachel Lane, if I can get the slides for the Warmington brand. Warmington has been building fireplaces for Kiwi homes since 1994 and continue to remain committed to delivering high quality products into New Zealand homes. Warmington fires are built in our factory in Auckland by a highly skilled team backed by our team of engineers and accredited in-house IANZ test lab to ensure all of our products are built to the highest standards. Now, without further ado, it is my pleasure to introduce our speaker for today, Rachel Lane Derrick. With over 2 decades of experience in the building industry, Rachel Lane has encompassed roles ranging from lighting design and sales to architectural draftsmanship, project management, and quantity surveying. Currently serving as sales and technical support at Rinnai, Rachel Lane collaborates daily with architects, engineers, and installers, providing crucial assistance in technical requirements, building code compliance, and design markups. Rachel Lane had been with Warmington Fires for 8 years before joining Rinnai, where she developed a deep expertise in these areas. Over to you, Rach.
Hi everyone, I am here today to go through wood fire design and a case study showing you the process of fires. Wood burner fireplaces in homes provide a long-term, low-cost heating solution. When a house is designed around a central heating source and consideration has been taken in regards to a layout, heat flow and wood storage, the end user gets an easy-to-use, high-heat way to keep their family warm throughout the colder months. Why choose a wood burner? There is more heat output than a gas fireplace. Heat outputs of wood fires range from 6 kilowatt right up to 35. You can cook on them or in them. There is water heating options available in a range of sizes, cheaper source of heating. Wood is a renewable resource in New Zealand. It is an efficient and eco-friendly way to heat your home. There is different sizes available to suit any size home. We use a rough guide of 1 kilowatt heat output to 10 square metres of floor area when sizing a wood burner for a home. It is not reliant on power, great for off-grid installations or unreliable power in New Zealand. There is a wood burner available for every part of New Zealand. And today's topics we will be covering advantages of wood burners, why you would have one and the benefits and advantages of them, the types of indoor wood burners and slow combustion fires, how they work, combustion air, new builds, ventilation and inbuilt models, position of wood burners in the home and the best layout for these, NES regulations, clean air requirements, how to find the information, then the ECAN list, a case study showing a project from start to finish, NZHHA and support from Warmington available, and we will send out links to the websites at the end. We have three main types of wood burners on the market in New Zealand. Open wood fires with no door on them, either a steel firebox like a Warmington SI indoor range or the traditional bricked fire range, and slow combustion inbuilt fires with doors on them, example the Warmington Vogue. Here are some examples of slow combustion wood burners. The third main type of wood burner is the slow combustion freestanding wood burners. Examples shown are the Warmington Tasman, the Southern Series fires in a range of sizes and the oven option, the Studio stove and the oven with coloured options available, and the newest, the Studio Compact series in 3 different versions, a pedestal, log box and wall mount available. Some of these options will be NES approved, some won't be. Each fire will have its own requirements and you will need to check with the manufacturer for these. How to choose the right wood burner. There are many different aspects to choosing the right wood burner for your project. What is the site requirements and what are they allowed to have? Example, are they in the clean air shed, as this will determine the choice of fire they can have. If they are, we move straight to the approved wood burner list. If not, have they got 2 hectares? If they have, they can have any fire they like. Then we move on to what is the purpose of the fire. Is it the only source of heating? Are they needing to cook on it or in it? Are they heating water with it? What size do you need? This will be mostly answered by the second question alongside doing your H1 calculations for the building and understanding your client's heating requirements. What type of look does the client want? Some clients have a very specific look they want right from the start, e.g. a steel or bricked fire, a large flame window or small window. Then once determining the above, we will have a very clear idea of what the fire they want and can offer the accessories to go with it. Example, gas starters for open wood fires, wetbacks and spark guards, etc. How does a Warmington wood burner work? The diagram shows the basic principle of how a slow combustion fireplace works by turning the 3 main components for fire into heat. For a fire to operate correctly and efficiently, you need oxygen, fuel and heat at the correct ratio to work. Wood burners take oxygen from within the room and you can control this through the damper on the front of the fireplace. Combustion air also enters through a preheated secondary inlet to provide the correct mix for optimum combustion. Combustion flue gases are released up the flue after the gases have been redirected back through the fire by the secondary air. This process produces clean, efficient heating. How does a wood burner heat the room? by allowing the cold air in the room to travel up the side of the firebox and into the room. Most freestanding appliances use this method. An inbuilt fireplace works in two different ways to get its combustion air. Warmington open wood fireplaces require external air to feed them. This is extremely important in newer homes due to how airtight they are and mechanical ventilation systems installed which affect the combustion air inside houses. Warmington Fires takes almost all of their combustion air through the KTX system, which means you will not get backdrafting into the room or spilling into the room. Some combustion air comes from the room when the fire is first lit, but to keep an open wood fireplace going well, you will need to be able to supply it with combustion air somehow from outside. When you are putting in an open wood fireplace in the middle of the house, we recommend running 2 × 100 diameter plumbing pipes in the slab to the outside air. Before the slab is poured, this is the easiest method for getting the external cold air to the firebox, and where it terminates outside, you will just need to have a vermin-proof mesh over the termination. If your firebox is situated on an external wall, you can have the vents directly from the back of the firebox to outside and use something like a subfloor vent to cover the holes. Being aware not to decrease the volume of the air required, which is 2 × 100 diameter vents or equivalent volume. The vents need to be as close to the base of the firebox as possible for the fireplace to be able to pull that combustion air in. The vents also provide the cooling air to the cavity, which is required for the tested installation to keep the cavity cold. Air pressure. This is a common problem we are seeing in new builds. When we have positive air pressure in the home, the fireplace will work well. If we have a situation where the home has negative air pressure, the fire will suffocate and go out or smoke back into the room. This will become much worse when any form of extract unit is turned on in the house. We need to balance the house and get the air pressure correct at the design stage of the building. With airtight homes and large extraction units, in bedrooms and kitchens, we need to consider the effect this will have on the fireplace. An open wood fireplace can use up to 22 cubic metres of combustion air per kilowatt of heat per minute. Some constraints to think about with tiny or smaller new homes is where the fire will get its combustion air from. As our previous slide showed, the fire takes its combustion air through the front of the fire, which is from within the room. If the room is airtight, the fire will run out of combustion air. We need to allow for natural ventilation in these smaller homes to allow the fire air. Often these homes are small and run out of air reasonably fast with a fire burning. Once a house is built, the only solution is to leave a window open by the fire or a door, which defeats the purpose of having such a well-insulated building sometimes. There are other solutions, as a wear vent installed in the wall behind the fire will allow combustion air in. Warmington has a suggested solution. When positioning a wood burner in a home, it is best to look at the airflow of the house and how the heat will be distributed to the bedrooms. We want to position a wood burner considering how it will be used, the best position for the family using it, and sometimes ease of installation. We have 2 examples here in a home showing the best position for installation. Option 1, we have a Warmington Studio wood burner positioned off a wall in a lounge area. The room has a wall separating it between the lounge and the rest of the house, and this position puts it quite far away from the opening. So we will not have a very good heat distribution throughout the house. The proximity to windows also raises another issue, and in around the blinds and curtains. These will need to be held back or fixed in some way that they cannot blow onto the fireplace at any point. This is part of the AS/NZS 2918 standard for wood burners. Windows also do not hold the heat in a room very well compared to a solid wall, so the fire will not be as efficient in this space due to being so close to a window as well. Option 2, the Warmington Studio wood burner is placed in the corner as close as it can be to the main hallway area to distribute heat down the hallway to the bedrooms. The walls are solid both sides, so more heat retention in the room, and the fire can stay at a hotter temperature for longer. Also, the dining area will benefit from the radiant heat as well. Clean air regulations for slow combustion and all wood fires. As you'll be aware, in New Zealand we have an air pollution problem, and one way the government has chosen to address this is through the regulation of wood burning appliances. In New Zealand, all properties that wish to install a wood burning appliance within the designated clean air shed need to comply with the NES regulations at a minimum. In 2005, the NES introduced the clean air regulations together with two new standards, AS NZ 4012 and 4013. Each council can set their own limits that are stricter than the NES regulations but aren't more lenient. As you can see by the graph, it is defined by two areas. Rural, which means the property is outside the clean air shed and has 2 hectares of land or more, and urban, which means the property is within the clean air shed and has less than 2 hectares of land. You can see there are some exemptions to these rules on the right-hand side, but once again you need to check with the council for each site to confirm their requirements. Other exemptions to this rules are properties that are heritage listed. Fireplace examples. Ultra low emissions burners, urban, clean air approved fireplaces, and rural, any type of fireplace. This is the air shed map. This is a view of what you'll see when you use the eCan Clean Air Shed online tool. You can type in the site address and it will display the site. And if it is within the clean air shed, you will see the blue bubble over it as shown. This is the first step in checking to see what the requirements are for a site. Some councils have imposed more stringent rules requiring ULEB appliances. You will need to check each council's requirements for each build you are working on. Now we'll move on to the case study. We've generously been given a case study of a fireplace that was designed and installed by the team at Fire and Living Limited. The Fire is a Warmington traditional 1 metre with a custom adapter. The team at Fire and Living can handle any wood or gas fireplace supply and install. They work closely alongside us at Warmington but can provide you with a one-stop shop from design right through to install on site for all fireplaces. The Warmington traditional fireplace allows for a brick-lined fire to be installed indoor or outdoor. We use a steel firebox with a heat cell around it so it can be installed into timber framing or concrete. The steel firebox comes with a full-width damper blade, so you still have control of the fire, and K-Tech air technology, which allows the fire to draw combustion air in from outside to feed the fire, therefore not getting smoke in the room and causing negative air pressure. These fires come in a range of sizes and allow for the customer to have a beautifully finished open wood fire in their home. Once we establish what type of fireplace the client or architect wants, we can start looking through the plans. We can see here we have a plan view showing the position of the fireplace in the room, the space it needs to heat, and what the structure is made from. We also normally have some indication of the finishes they might have around the fireplace as well. We then look through the architect's plans to get an idea of dimensions. The second plan shows us the concrete structure makeup and refers to sections for additional information and gives us the sheet numbers to find this information. The third plan on the sheet gives us the roof makeup, pitch of roof and materials. We at this stage can see we will have a full chimney type structure coming through the roof, so we know the flue will not be unsupported. It will have protection from the wind as well, looking at the roof design. In the full roof plan, we can also see if this design will meet the 3 metre radial clearance required for the flue termination, as we can establish if there is a higher roof nearby or how close it is to the highest point of the chimney sits. We can also see the roofing material here, and the notes on the plan show us what the material is, so we can comment on and flashing requirements or clearances needed. This is especially important for membrane or rubber roofing materials, as these cannot withstand the heat from wood flue systems and need clearances from the flue system to make sure there is no damage to the roofing material or glues used. When we take a standard or custom design fire, we need all this information to establish if we can meet the clearances required from the tested specifications or AS/NZS 2918. Then we go through the set of plans sent to us. We are looking at the flue and chimney heights to determine if a flue system will be single-lined or double-lined to comply with AS/NZS 2918. We need to know the final chimney heights and the type of flashing being used to check the flue. Can it be supported and the weather tight to comply with E2? Other details the elevations show us is where the combustion air is coming from for this fireplace. Often the combustion air is shown in vents on the side of the fireplace, the structure, or at the back of the fireplace. These would normally be noted as K-Tech vents. K-Tech vents are required to be 2 times 100 diameter vents or equivalent volume of air. So you can just make one large vent or have 2 smaller vents as long as the volume is the same. The vents need to be located as close as possible to the firebox base to allow for the cold combustion air to feed the fire. We do not want the vents above the fire, as the fire will not draw the cold air down to it. Next, we look at the chimney termination. We can see they have a box type structure around the top. We need to check to make sure the clearances from the flue meet the Warmington clearances required. All of these drawings are from the main set of architect drawings. Ideally, we'd want a full set of fireplace drawings to go through. These are example documents Warmington used to give clearances to combustible materials when you would like to build around a flue system. We do not recommend impeding the flue system or covering it, but in some wind zones and areas it is the only way to reduce wind noise to a flue system. AS/NZS 2918 does not recommend to cover a flue termination as well. Ideally, we want the flue to be able to draw and get rid of smoke naturally without anything in the way. And if the structure is not built to allow this, then this can affect how the fireplace works. If you want to put a box type structure around the flue, then each side must have the total opening of the same volume as the flue diameter. Example, if you have mesh on this side of the cowl system, the openings in the mesh must equal the volume of the flue diameter at the minimum to allow for the volume of smoke to escape. The example of the cap flashing shows the installer or roofer needs to know on site. The flashing turn down on the sides is determined by your E2 flashing lap calculations, and the upstand is established by the insulation under your flashing area on the specs. The final dimension needed is the spigot diameter. This is determined by how you will get the hot air out of the chimney cavity, either through the top flashing or through vents on the side of the chimney cavity. In this job, as there was custom elements involved, the architect provided detailed construction drawings showing details we need to establish how to build the custom items needed for this fireplace. The architect has provided us with a detailed plan showing the space they have allowed for the firebox. In plan view, this allows us to use these dimensions and cross-reference if this space is big enough for the fireplace to be installed and meet the specification requirements. Another big item we would note at this stage is when you have someone look at this drawing is how is this fire going to be installed. These fires, just the steel fireboxes, start at 250 kilos. So they're not easy to lift and move. Therefore, thinking about how these fires are installed becomes quite critical to the project. As we can see, the construction is to be concrete, presumed at this stage either poured in situ or panels lifted into place. Either of these options would have effects on how we will get this fireplace into the position on site. Looking at this sort of information is helpful for everyone involved in how the final product will get to site and be installed. It would be easy to say it is someone else's job, like the installers, but the reality is if you can't install the fire, you have no sale. So when we get sent plans, we look at the whole project. This includes the site location, access, often becomes an issue with these large fires, and the bricks. Often lifting these items into site becomes quite challenging. So in this case, in discussion with the builder and the architect, the fire was fitted with a lifting hook to lift the fire down the concrete enclosure into the position it needs to sit into. Other installation options in this case would have been to have the fireplace enclosure back and sides constructed, then the fire placed in the cavity, then lift the front panel in, or if poured in situ concrete, have the fire sitting on the plinth, then pour walls around the fire to a certain height, then remove all timber framing again once set. We can see in our section picture the top of the chimney flashing and cowl termination. We need to know how the chimney will be vented as per our previous slide. When we look at a Warmington traditional fireplace, we have the following main parts we need to consider. The main steel firebox, which houses all the working parts of the fire. This is also the main part that has been tested and complied to AS NZS 2918. The firebox is the main component which all other parts get connected to and built around. The adapter or gather that sits on the top gets bolted to the firebox on site and sealed with mani-seal by the installer on site. We can slope adapters forward and backwards as required to get the fireplace past framing or block work. This also allows the flue to be supported on the firebox itself. No need for strapping and supports for the flue system weight. This is a preferred solution rather than having bends in the flue, which needs supporting and are hard to clean. The damper blade in the traditional fire is full width, left to right, and allows for the damper to be adjusted so you have control over the fire. You can see the K-Tech air vents in the brickwork, allowing the cold combustion air to the face of the fire. The flue system shown is a standard 3.6 metre flue kit, which is the minimum required for this fireplace. You can extend a flue system, but you cannot make it shorter than the tested system. When we are looking at the architect's plans, we are referring to our own technical drawings to make sure it complies. The picture shown is the traditional fire in a concrete enclosure, what you would see if you download the DWG files from our website. If the clearances and sizes don't meet the minimum, then we need to go through what they can fit and if moving the framing is an option. We show in all our downloads the clearances required, and you can access these from the Warmington website. Fire and Living prepared detailed drawings and plans to submit to the builder and architect showing requirements and custom components. On their drawings, we can clearly see the K-Tech air in supply at the base of the fire. It is coming through the plinth and allowing the air to come from underneath the fire to supply the combustion and cooling cavity air required. We can see the custom componentry, the adapter in this case, at the measurement needed for manufacture. We can see the design of the brickwork in this case, a traditional shape inside the fireplace with a stretcher bond pattern to be bricked out on site. We can also see they're going to get a gas igniter system, which means that they will not need matches or kindling to light their fire. They will only need a switch on the wall. These construction photos give you an idea of the logistics that go into placing these big heavy fires into their final positions on site. We can see the precast base being lifted into position with a crane. Then you can see the fireplace with the adapter connected in, lifting down the chimney chase, allowing the fire to be placed in the correct position on site. What is not shown in these pictures is how the flue system gets connected. The installer will still need to get into the cavity to fix the flue to the adapter and build the flue system to the top. Most of the time they will climb inside and use ladders to build up and get access out the top. Shown here is the fire being lowered into the concrete cavity. You can see the finished cowl and mesh box around the top of the chimney structure. As you can see, this is a very exposed beach setting where this fire is, so the mesh box will stop the force of the wind blowing across the cowl. Once the client decides they want a traditional fire, we ask them what type of styles and layout they want. Either Westminster, which is a side walls sloped and the rear sloped, Westminster straight back, which is side walls sloped and the back is straight, and a traditional, which is a side and the back wall are all straight. This allows us to manufacture the right firebox for the bricklayer on site. Then they need to choose the size bricks and pattern they want to brick out on site. Herringbone uses the most bricks and has the highest labour cost due to the amount of cuts and time to lay. Clients can use a mixture of sizes and styles if they like as well. All bricking gets done on site by hand and at a minimum takes around 3 to 4 days for a simple job. The bricklayer needs an area to cut with a saw and water as well. Some example pictures of how the brickwork goes into the fires and the level of skill and detail needed. One thing that is often missed is the amount of mess and dust that will be created as part of this brick out. Ideally, the fire should be installed as soon as the house is weather tight, but framing still open to inside the room. This allows the installer full access to the flue and fire system for installation. Then before any internal wall linings are up, we want the bricklayer to start. He needs his saw to be as close as possible and allowance made for his mortar and dust. As you can see, the bricks are built up in layers, slowly being mortared in with refractory mortar as they get higher. You can see the K-Tech air bricks in these photos, which allow for the cold combustion air to the fireplace, allowing the fire to pull as much combustion air required to work. Every bricklayer has their own technique in laying and assembling these fires. Unfortunately, this is not something you can study anymore. It is a taught trade on the tools, and there are very limited bricklayers doing this detailed work. Calling the bricklayer after the painting is done on site just ends up costing more and taking longer. So this is something to consider when putting a build timeline together with the construction or project manager. Final renders of how the fire was expected to look and how it turned out on site. These were presented to the client in the beginning of the project so they understand the look they will get and the proportions. With this level of planning and management, the client got the best result on site. Some more construction photos. As you can see in the second photo, we can see the K-Tech air holes at the base and the access panel for the gas igniter system. It is important to think about access and serviceable parts when specifying all appliances in a build. Note the finishing details around the opening, the steel edge, which means a seamless look into the fireplace once completed. This fire is completely undercover, so there is no worry about water in the front, but often on our open wood fires you need to allow for the recess for the weather shield to sit in. All these details are best discussed and detailed early on with your clients, as it gives all the suppliers and installers the correct information and they can price for the complete job from the start, meaning no hidden costs for the clients later on. The fire finishes flawlessly inside the concrete structure with the details all sorted before the fire turned up. Other items to consider, which I tell homeowners to think about, is wood storage as well. Open wood fires burn through a large amount of wood and large sizes typically. So having somewhere close to store wood out of the rain is a must. Clients often don't like the look of a wood store inside, but then end up by using a plastic bucket or similar to store their wood in and regret the decision later on. New Zealand Home Heating Association and Warmington. The association is dedicated to providing the solid fuel home heating industry professional development, advocacy and advice for these purpose of promoting renewable and sustainable sources of energy. They have lots of good tools and advice on their website, and people who become members can get support when needed from them. This is also where you can go to see who is registered installer and for wood and gas appliances. Also chimney sweeps in your area. They run courses throughout the country, which you can attend to get a better understanding on the requirements for fireplaces. Warmington Fires are still manufacturing fires as they were previously before Rinnai brought the company. We have staff available to help with all questions and markups as required. You can send through your plans and designs to us, and we can advise on what is required on site.
Thank you, Rach, for a very informative presentation. Now it's Q&A time. We've also put up the contact details of our specification team at Rinnai, so please get in touch if you have more questions following today's webinar or require assistance for specific projects. Also a reminder to please contact us if you're interested in morning tea presentations or a quick catch-up on product updates. For those of you in Auckland, please do stay till the end, as I will be talking about our exciting Rinnai showroom launch event at Residium. Our lead design and test engineer, Oystein, has joined us for Q&A. Thank you for joining us, Oystein.
Thank you, Alice. Thank you for the introduction, and hello to everybody.
Hi. So here are some questions we received prior to the webinar. So let's start with these questions first. Oystein, can you make an older wood fire to be clean air approved by adding parts to it?
So unfortunately, if it's an old fire that has not been tested to 412, 413, there's no way of making it clean air approved, because all fires have to be tested at an IANS approved laboratory, and they don't allow for any changes to the appliance, and it needs to go through that full process before it can be approved. So only fireplaces that has that approval on them, on the specifications, are the ones that you can use.
Thank you, Oystein. And can you put a door on the open wood fires?
So any fire that has been sold as an open fire, you cannot put a door on it. Any modification that is done to a fireplace can potentially be dangerous because it changes the product from what it was tested as. So if do any aftermarket changes or any modification can potentially be a big fire hazard. So we would never recommend any modification to a fireplace.
Okay, thank you. And I think we're a bit quieter today. What I'll do is, what I've done is I've posted a survey link in chat for today's webinar, which only takes 1 minute to complete. And we're very keen to know the topics that you would like to hear from Rinnai and your feedback for us to make these webinars better for you. It's also a way of us knowing that you've attended today's webinar. So I think that's all the questions today. Now, what's coming up before we wrap up? We do have some very exciting news to share, especially for those of you in Auckland. We're very pleased and excited to announce the Rinnai showroom launch event at Residium will be held on Thursday, 22nd of May. This will be an after-work CPD event with food and drinks provided. So please save the date and keep an eye out for your official invite next week. You'll be able to explore a wide range of products, including the Warmington Outdoor Nouveau Pizzeria, Studio Compact, Studio Stove, and a traditional indoor wood fire fully brick-lined with herringbone style that Rachel mentioned during the webinar. And Rinnai holographic fire, electric fire, linear gas fire with flame tech logs, also our hot water solutions, our hydro heat, hot water heat pump, integrated and split, and infinity graphite, and selection of Rinnai heat pump systems. You're also welcome to book appointments with our specification team at Residium for project advice and product selection support, or just to see the fireplaces in action. Thank you again for joining us today. We hope you found the session useful, and we'd appreciate it if you can please take a moment to complete the short survey after this. Take care and stay warm out there with the wind and rain today. Thank you again. See you next time. Mā te wā.